In this video, you will learn about congruence and similarity. So let's begin by talking about congruence. What congruent means is two or more shapes that have the same size and the same shape. For example, here we see two different triangles that are congruent. They are the same size and the same shape. Now with any sort of congruent shape, we have what is called corresponding parts. Corresponding parts would be the parts that go together. So looking at this triangle, we have different vertices or vertex that would go together. We have angles that would correspond, and we have sides that would correspond. And here we see it all in this table, where in this first column, we have the corresponding vertices. So this point A up here corresponds with point D up here. So A and D correspond. Here in the bottom left, we have point B. Bottom left over here, we have point E. So B and E would correspond. And C and F would also correspond as well. Those are both in the bottom right. So those are the corresponding vertices. We also have corresponding angles. So angle A and angle D correspond. They're both in the top. Angle B and angle E correspond. Then angle C and angle F correspond. And that is what I see here in the second column. And then thirdly, we have corresponding sides. So this left side over here, AB, corresponds with the left side over here, DE. So AB corresponds with DE. And then BC on the bottom corresponds with EF on the bottom over here. And then AC corresponds with DF on the side. So those are the corresponding parts of this congruent triangles. So congruent triangles would imply that the corresponding angles are congruent and the corresponding sides are congruent. So that means, for example, that AB and DE would be the same length, AC and DF are the same length, and BC and EF are the same length. And then all the different corresponding angles would be the same as well. So this fact right here leads us to our definition of congruent triangles. So we say that two triangles are congruent if and only if their vertices can be matched up so that the corresponding parts, which would be the angles and the sides of the triangles, are congruent. Alright, so we want to make sure that every corresponding part would match up so that they are congruent. So therefore, we can conclude that the corresponding parts of congruent triangles are congruent. And the abbreviation of that statement can be found by taking each of the first letters of the words, and we get C, P, C, T, C. And this is used a lot when you work with proofs in geometry. So instead of using this whole phrase within a proof, we can use this abbreviation instead. Now when you're writing congruent shapes, it is important that you have the corresponding vertices matched up so that they're in the same order. So for example, if I am writing triangle, let's say BAC over here, we're trying to show that it is congruent, which by the way, this is your congruent symbol. It's an equal sign with a little squiggly line above it. But we're trying to show that this is congruent to this other triangle over here. It is important that the letters are corresponding. So for example, the letter B comes first, and that corresponds with E over here, so E would have to go first when I write this triangle. A comes second in the way I wrote this first triangle, and the A corresponds with the D for the other triangle. So because A came second, D would have to come second over here. And the C corresponds with F, and C came third over here, so F would come third over here. So I can write this as triangle BAC is congruent to triangle EDF. Now it doesn't matter the order in which I put the first triangle, so I could be doing triangle ABC, for example. The only thing is just be careful when you write the other triangle. So again, A corresponds with D, so A was written first, D would need to be first over here. B corresponds with E, and because B came second, therefore E would come second as well. Then C corresponds with F. C came third, so F would come third as well. So as long as the corresponding parts are in the same order, it does not matter in which order I write the letters. So I could write the first triangle as BAC, or ABC, or CAB, or ACB, and there's different ways we can write that, and it'll still be okay as long as the other triangle, the letters are in the same order as the first triangle. Now here are two other triangles which at first glance might not look congruent, but these actually are. The only thing that is different is that the one triangle is flipped over and is facing the other direction. So the question is, with these congruent triangles, how would I write that these triangles are congruent? So we want to make sure that we have the corresponding vertices matched up. So the question is, which vertex corresponds with which vertex over here? Well, notice the sides. We have 4 inches and 4 inches. All right, so those sides go together. We have 6.5 inches and 6.5 inches down here, so those go together. And then 7 inches and 7 inches go together. All right, so when I see this, I pick one triangle to start with. So for example, I'd write this first triangle as triangle ABC. And it's congruent to this other triangle, but we just need to make sure we get the letters matched up. Well, notice that A right here is between the sides that I've underlined with 1 line and with 2 lines. So same thing over here. I need to find which point is between the sides that have 1 line and 2 lines under them. And that's going to be right here, point Y. So A corresponds with Y. And then looking at B, B is between the sides that I underlined with 1 line and with 3 lines. So over here, same thing, find the point that's between the sides with 1 line and 3 lines. And that's going to be right here, point Z. That's between those 2 sides. So Z corresponds with B. So B came second, so Z would come second over here. And then by default, X would have to correspond with C. So then C came third, X would come third over here. All right, so just be careful when you are trying to match up the vertices that you are doing so correctly. So looking at the same picture, we can use this concept that the corresponding parts of congruent triangles are congruent to determine which sides and which angles are the same. So we can already see from the picture with the side lengths that AB is going to be congruent to YZ. So this side corresponds with this side over here. Okay, BC, the bottom, corresponds with XZ, or ZX over here, because they both are 7 inches. And then AC is congruent to YX, because those both are 6.5 inches. But now looking at the angles, we see that angle A up here, that angle would correspond with Y down here. So those angles are the same. And then right here, this angle, the one here at B, would be congruent to this angle up here, the one up at Z. And then C, this angle, would be the same as this angle right there. And we could write that out if we wanted to, where we have, angle BAC is congruent to angle, and that was what, XYZ, this angle right here. And then over here, the one at B, that can be named as angle ABC. That's congruent to the angle here up at Z, which would be YZX. And then the angle here at C with the vertex, we have angle ACB, is congruent to, and that corresponds with this angle, angle X, which would be YXZ, angle YXZ. So those corresponding parts are congruent because the corresponding parts of congruent triangles are congruent. Now, one last picture as we talk about congruent polygons. Here we have 2 polygons that have a lot of different sides to it. So just because it has more sides does not mean that we have different rules. The same rules apply as with triangles, as it does here with this polygon, as it does with any congruent polygon. Alright, so with this, the corresponding sides are the same and the corresponding angles are the same. So like the top, like AB, would correspond with ST. Those are the same length. UV would correspond with CD. Those are corresponding and those are also congruent because they're corresponding. Alright, so if we want to write that these two polygons are congruent, this first polygon, we pick a letter to start from. So let's pick A to start with. And when we name a polygon, we start at any letter and then go either clockwise or counterclockwise. So if we go clockwise around the different vertices, we have polygon A, so A, and then B, C, D, E, F, G, H. So we just write out all the letters, A, B, C, D, E, F, G, H. So this is polygon that. And then over here, make sure that we start at the same place. So A corresponds with S. And then we make sure all the letters that correspond go in the same order. So if we just start here at S and go in the same direction as we did on the other one, we should be good to go. So polygon A, B, C, D, E, F, G, H is congruent to polygon, and then the letters S, T, U, V, W, X, Y, and Z. So we just write out all those letters. Alright, so the same rules apply, and when we write a polygon, we just use all the letters from the vertices. Next we have what is called similar shapes. Now similar shapes are two objects that are identical, but the size could be different. So for example, pretty much any drawing that you create would be similar to the actual object, right? When you draw a tree, you're not drawing the same size as the original tree, right? You're scaling it down so it's a much smaller picture of the actual object. So that is the idea of similar shapes. Now, two polygons are similar if their vertices can be paired so that the corresponding angles are congruent and the corresponding sides are proportional. So for example, here we have two different quadrilaterals, and we are told that they are similar. So again, if they're similar, that means all the corresponding angles are the same and the corresponding sides all have the same ratio. So if these are similar, and we are told to try to find measure of angle LON, which is right here, notice that this angle corresponds with the bottom left angle over here. So they're corresponding, which means that this angle would also be 70 degrees. So all the angles are the same, and then we said that the sides are in the same ratio. That ratio is what is called a scale factor. So if we are told that these two triangles are similar, quadrilaterals, if these quadrilaterals are similar, we would first of all use this notation right here. That means similar. Alright, and we are told to find the scale factor of PQRS to LMNO. So the scale factor of the smaller quadrilateral to the bigger quadrilateral. Well, the scale factor is a ratio. So if we try to find corresponding sides, we can find the ratio. So for example, PS is on the left side. That corresponds with LO on the left side. So we have the 4 corresponds with 8. The 6 on the top corresponds with the 12 on the top. The 8 on the bottom corresponds with the 16 on the bottom. If I pick any pair of corresponding sides, the ratio will be the same. Right? If I do 4 to 8, 4 over 8 is equal to 1 over 2. If I do 6 to 12, that also is 1 over 2. 8 over 16, again, is 1 over 2. So the ratio is called the scale factor, and the scale factor is 1 over 2, or we can write that as 1 to 2. Now, take note that the order does make a difference. So the scale factor of PQRS to LMNO means I take a side from PQRS. So we take the side like 4 or 6 or 8 and then put that on the top, or put that on the side like this. And then to LMNO, this quadrilateral over here, we pick the corresponding side from this shape. And if we look at the 4, the 8 corresponds with it. So 4:8 would simplify to be 1 to 2. So if I were to say this the opposite way, tell me the scale factor of LMNO to PQRS. LMNO is the bigger quadrilateral. PQRS is the smaller. So I pick a side from the bigger quadrilateral, such as the 8, and then pair it up with the corresponding side of the smaller quadrilateral, which would be the 4. So 8 to 4, which would simplify to become 2 to 1. So again, make sure that you are being cautious with the order in which you're putting the numbers. So what the scale factor does for me is, one, it confirms that we do have similar shapes, but then two, if we do have similar shapes and we have the scale factor, we can use the scale factor to calculate a missing side length. So we said the scale factor is 1 to 2, or 1 over 2, and if we're trying to find this length over here of mn, I can use the scale factor. I know that this ratio of 1 to 2 will be the same with any pair of corresponding sides. So 4/8 is 1 to 2, 6 to 12 is 1 to 2, 8 to 16 is 1 over 2, 5/x is also 1 over 2. We just don't know what x is, but that ratio, 5/x, would also equal 1 over 2. So what I can do is I can use this to solve for x. And remember, to solve a proportion like this, we have a fraction equaling a fraction, I can solve by cross multiplying. So I do 1 times x to get x, and then 2 times 5, that gives me 10. So my solution is that x equals 10. And that's the side length of mn over here.